Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I want to talk about the XAML syntax that we wrote in our first pass at the HelloWorld app. Hopefully you could see how the XAML that we wrote, or that was generated by dragging and dropping controls from Toolbox onto the designer surface, or by making changes in the properties window, either way, how it impacted what we saw then in the XAML page or in the phone preview pane, and how the three panes kind of work together to generate the XAML, which will ultimately be compiled into a .NET assembly. So it's relatively easy to figure out the absolute basics of XAML just by looking at it. I mean, we were able to see here that we've got a grid and we've got some buttons and things of that nature. However, what I want to do in this lesson is point out some of the features and the functions that may not be obvious at first glance. And so in this lesson, we'll talk about the purpose and the nature of XAML, and we'll compare it to C#. And then we're going to talk about the special features of XAML, little hidden features of the language that might not be obvious when you're first staring at it. And my aim is that by the end of this lesson that you'll have enough knowledge so that you can look at the XAML that we write from here on out and be able to take a pretty good guess about what it's doing even before I attempt to explain it to you. Okay? So at a very high level, what exactly is XAML? Well, in the previous lesson, I made a remark about XAML that it kind of looked like HTML. That's actually no accident. XAML is really just XML, which stands for the Extensible Markup Language. And I'll explain that relationship in just a moment. But at a higher level, XML looks like HTML in so much that they share a common ancestry. So whereas HTML is specific to structuring a web page document, XML is more generic. By generic, I mean that you can use it for any purpose that you devise. You can define the names of the elements and the attributes that you need to suit your needs. So in the past, developers have used XML for things like storing application settings or using it as a means of transferring data between two systems that were never meant to work together in the first place. To use XML, you define a schema which declares the proper names of the elements and their attributes. It's kind of like the rules for my flavor of XML that I'm composing off the top of my head. So a schema is like a contract. Everyone agrees, both the producer of the XML and the consumer of the XML, to write and read XML to conform to those rules in the schema. They'll abide by the rules of the contract, in other words. Now they can communicate with each other if they can rely on a common syntax, a common language, a common name for elements and their attributes. So a schema is an important part of XML. Just keep that in mind. It's going to be important here in just a moment. XAML is a special usage of XML. Obviously, we see that, at least in this case, XAML has something to do with defining a user interface with not only positioning controls, but what type of control we want to display, and then its size, its shape, the text that might appear on that control, what happens when you click or do something else to the control, and so on. So in that regard, it's very much like HTML, right? If you're familiar with how to lay out web pages using HTML. But there's a big difference in so much that XAML is actually used to create instances of classes and set the values of properties in a declarative fashion. So for example, in the previous lesson, we created a button and a text block. Let me do this. Let me comment out the button like so. Syntax that should be familiar to you if you have used any type of XML or HTML syntax. The open angle bracket, exclamation mark dash dash to open a comment, and then the dash dash close angle bracket to close the comment. Now this code between those two delimiters will not be compiled. All right, it'll be ignored. You can see that our button has disappeared from the designer instance on the left-hand side. So now let's go to our main page.xaml, And, well, actually, one other thing that I want to do here, I'm going to give my grid a name so that I can access it from my C# code. So I'll give it a name equals my layout grid. And you'll see how that comes into play here in just a moment. Let me save that. All right, now in the code behind, in the main page.xaml.cs file, in this onNavigated2 section, I'm going to delete all those comments. And what I want to do is just paste in some code that I've written. And I'm going to use put my mouse cursor on the colors because it doesn't see the namespace that belongs to. I'm going to hit Control period on my keyboard and then add the using statement windows.ui. And you can see now that we have a similar button to what we've created in XAML. We've created that button now in C#. So I'll talk about the relationship between your main page.xaml and the main page.xaml.cs in just a minute. But here I'm merely writing code that will execute as soon as a new instance of this main page has been navigated to. The important takeaway is this, that XAML is simply a way to create instances of classes, and we can do the same exact thing in C#. In fact, if we run this app, I think it should work. Let me run it. And you can see it performs identically. So the XAML and the C# are almost identical. I added a background color red, and there's some other maybe size differences between the two, but essentially they're the same. However, it was much easier, or it required much less code to create the button control declaratively than creating it in C#. You'll notice that not only did I set the various properties, the name, the content, the height, and the width, but then also with the horizontal and vertical alignment, I had to use special enumerations. When it came to the background color, here I had to create a new instance of something called a solid color brush. We'll come back to that, and then give it the color I wanted to create. And here I had to manually wire up the click me button underscore click event in order to register that event handler with the click event of my new button. And then finally add the button to the children of the layout grid. All right, so quite a bit more code to accomplish essentially the same thing that I did here. All right. Furthermore, whenever I'm using the XAML view, you can see that I have immediate feedback in this phone preview pane. I can see the impact of the changes that I made immediately, but in the case of the procedural C# code that I wrote here, I wouldn't really know what it did until I actually run the application to see how the tweaks that I've added to my code actually work. All right, so there's some benefit from a tooling perspective to using XAML over using imperative C# code. All right? All right, so if you have a keen eye, let's take a look at this right here and take a look at my button.horizontal alignment equals windows.ui.xaml.horizontal alignment.left. All right? If I change this, let's just comment out this line and change this to just quote-unquote left. All right, you can see that when I do this, I get a red squiggly line indicating that I have a compilation error. And the error is that it cannot implicitly convert type string to windows.ui.xaml.horizontal alignment. All right, that might strike you as odd whenever you take a look at the XAML that we replaced. Here the horizontal alignment equals, and here we have a string, quote-unquote left. If these are equivalent ideas, then how is it that I can just type in a string left here, but here in C# I have to give it kind of the fully qualified class name and then the enumeration value and not just a simple string property? Well, the reason is because in XAML you get the benefit of this technology called a type converter. And essentially a type converter is just a class that can translate from a string value into a strong type. And there are several of these that are built into the Phones API that we're going to use throughout the series. Now in this example, the horizontal alignment property, when it was developed by Microsoft's developers, was marked with a special attribute in the source code which signals to the XAML parser to run the string value through a type converter method to try and match that literal string left with an enumeration value, hopefully windows.ui.xaml.horizontalalignment.left. Okay. Now, for example, if we were to just misspell the word left and leave off the T, you can see that, and actually let's go ahead and uncomment that out. You can see that I'll get an error and it'll say requested value left was not found. But if I add the T back to left, everything is just fine. Okay. You get a compilation error when you have a misspelling because the type converter can't find an exact match to convert into the enumeration values. So the first characteristic of XAML is that it's a succinct means of creating instances of classes, and in the context of building a phone application, it is used to create instances of user interface elements. However, XAML is not particularly just a user interface technology. It could be used for other purposes and other technologies, and it is, like for example, in the Windows Workflow Foundation technology. All right, so let's go ahead and add left back in, and I'll go ahead and comment this out just to here again, because I think we're going to use it later. All right, so let's take a look at the very top of our XAML page. You can see we have this open angle bracket page, and even though all the properties or the attributes of that element are actually moved to separate lines, you can see that they are all one long element. It's just for readability's sake that they're moved to separate lines. And then the end page tag is at the very bottom. So it is the parent for the main page.xaml. So while you're looking this over and you take a look at some of the things that are, for example, in lines number 3 through 7, you'll remember what I said a moment ago about schemas being a big part of XML. And so if that's the case, then where does XAML promise to adhere to a schema? Well, that's the purpose of lines 3 through 7. There are 5 schemas that this main page.xaml is promising to adhere to. Each of them are defined with an XML-NS attribute, I guess you can say, prefix. The first XML-NS, or namespace rather, is defined in line 3. And you can see here that it is the default namespace. In other words, there's no colon after the word XML-NS like you see in lines 4 through 7. And the rest of the namespaces in lines 4 through 7 will use that name colon combination. So just to be clear, for example, the X, so XML namespace colon X is the namespace that's associated with that specific schema. Each element and attribute in the rest of the main page.xaml must adhere to at least one of these schemas. Otherwise, the document is said to be invalid. In other words, if there's an element or an attribute that's expressed in this XAML that's not defined in one of those namespaces at the very top, then there's no guarantees that the compiler, which is the program that will parse through our source code and create an executable that will run on the phone, there's no guarantee that the compiler will be able to understand how to carry out that particular instruction. So, for example, in this example here that we've commented out, we would expect that let's take a look at the text block here. The text block element, we would expect it to be part of this default namespace because it doesn't have any letters like, for example, D colon or MC colon or local colon in front of the word text block. However, if you look at the name property, it has an X prior to it, and we know that will be defined, or the rules for it are defined in this namespace, schemas.microsoft.winfx/2006/XAML. All right. So I have a bright idea. Why don't we try this and see? Take a look at this definition so that we can understand a little bit more about it. So I'm going to copy that URL and paste it into my web browser, and oh no, it says the web page can't be found. Where is it? Well, the schema doesn't actually exist at that URL. That's because the schema is not published in the sense that you can go to that URL and view it like we just tried. Instead, a schema is simply a unique name, similar to how we use namespaces in C# to identify two classes that might have the same name. So the schema, and therefore the namespace in our XAML, keeps class names sorted out, kind of like our last name or our surname. To borrow again from that C# Fundamentals series, my last name is Tabor, and even my middle name is Theron, and so that will help to narrow down the possible Bobs that you might be referring to. Which Bob likes coffee? Remember that example? Robert Theron Tabor likes coffee. Oh, I know that guy. All right, so it's a way of disambiguating the names of classes that might be used inside of your code. So what's the fundamental difference between these two namespaces? It's subtle, but the second schema that's defined here, on line number 4, defines the intrinsic rules for XAML in general. The first schema in line number 3 defines the contract, or rather the rules for the phone's specific usage of XAML. In other words, the fact that we can work with the grid and the button and the text block and the other XAML elements without using a prefix means that they're defined in the default namespace. In line number 5 here, we have XML namespace : local, and this is just the topmost namespace for our project. So any custom classes that we were to create as we add them to the Solution Explorer, and we want a reference from within our XAML, we can just append the local : namespace in front of it and then use it inside of our XAML. And then finally, lines number 6 and 7, :D and :MC, define namespaces and schemas that we use to allow Visual Studio's phone preview pane here on the left-hand side to display properly. These instructions are ignored at runtime. That's why you see this MC : ignorable equals D. That means anything that's defined in MC, you ignore it whenever we are actually compiling and running our application. All right, so it's purely for the purpose of the designer, not for the purpose of actual compilation. And we'll see where that comes in as we're working with dummy fake data later on in the series as we're looking at binding to data to display in our app. Okay, and so I know I've left probably some big questions unanswered here. We could spend a lot of time talking about the specifics, but the main takeaway is that our code, or this code that's at the very top of our page, defines the rules that your XAML code must follow. You almost never need to modify this code, but if you remove it, you could potentially break your application. So I'd encourage you to not fiddle around with it just yet until at least you have good reason to, and we will add some attributes to the page later on in the series. And then that final attribute there, background equals, and then this open closing curly brace syntax, theme resource with this name, application page background theme brush. We'll talk about that at length in an upcoming lesson on themes and styles. So just let's put a bookmark in that thought and we'll come back to it a little bit later. All right, I want to work more on, or talk more about the relationship between this XAML file and this .xaml.cs file. All right. So you can see in the Solution Explorer that these the XAML pages have a little arrow next to them, which means that you can drill down. And so you see that there's this relationship between the main page.xaml and main page.xaml.cs. All right. Furthermore, if you look at the C# or the .cs version of this file, you'll see that at the very top it defines a public partial class main page that derives from page. All right. So the key here is partial class main page. And if you take a look at the other half of this equation, you can see here is the page class, and here we're creating a class called HelloWorld.MainPage. HelloWorld is going to be the default namespace because of the project name HelloWorld, but the class name is MainPage. All right. So while it doesn't use that term partial anywhere here, it's like its procedural counterpart that we just looked at, it does indicate the relationship between the two. Now, why is it important that I point out that these are really connected together by the class? And you can even see here, this name has this keyword partial. Well, the relationship means that the compiler will combine the output of the main page.xaml and the main page.xaml CS into a single class. So this means that they're two parts of a whole. And that's an important concept, that the XAML gets compiled into intermediate language, just like C# gets compiled into intermediate language, and they're both partial implementations of a single class. So this allows you to create an instance of a class in one file and then use it in another file, so to speak. This is what allows me to create an instance, for example, of the button class like we did here that I've commented out, and then be able to reference it or utilize it from this code behind here in the mainpage.xaml.cs. And we're going to see more examples of this a little bit later on in this lesson. Back on our mainpage.xaml. Since XAML is essentially an XML document, we can embed elements inside of other elements to kind of connote containment or parent-child relationships. And we've already seen this example, right? We have at the topmost level a page here owns a grid, and inside that grid we have a button and a text block. Or perhaps more correctly in XAML parlance, that page's content property is set to an instance of the grid class, and the grid has a property called children, and these two classes are added as children to the grid control that we added. All right, so depending on the type of control that you're working with, the default property can be populated using this embedded style syntax. So let me go ahead and uncomment this out again. All right, so in this particular case, I can set, as you can see, the content equal to click me, or if I wanted to add a second button and use a slightly different style, I can do this. I've added a second button now, but notice that instead of a self-enclosing element syntax, I have a open button element and a closing button element, and then between them I just have the text hi. And since content is the default property for the button control, I can just type whatever I want here and it will attempt to put that inside the content property for my button control, right? Like so. So that's default properties. In some cases, merely setting attribute values masks the complexity of what's really going on behind the scenes. And a good example of that is, for example, if we were to take this button and set the background equal to red for this button, let's do that. We can see that we can change the background of our button to red by merely, again, setting it to this quote-unquote red, this literal string value of red. All right, but if you take a look at the equivalent code here, let's comment this out and move this back up here, like so. If you take a look at the equivalent of that line of code here in C#, we can see that I'm setting the background to a new instance of a solid color brush, giving it an enumeration of type windows.ui.colors, and the enumeration value is red. All right. So this is another great example of a property type converter that we learned about earlier in this lesson, but some attributes are simply too complex to be represented in this manner using this style right here. All right. So when a property is not easily represented as a XAML attribute, it's referred to as a complex property. So to demonstrate this, what I'm going to do is actually remove that background color like so, and I'll actually remove the word hi, and I'll just put this as a content equals hi. Okay, so we can keep our eye on that. And then what I want to do is actually, the easiest way to illustrate this is using the properties window. I'm going to go to the brush settings, and I want to make sure that the background is selected, and I'm going to select the gradient brush tab. in order to change the values inside of this. And what I want to do is move the selector all the way to the upper right-hand corner, like so. And you can see how this affects, let me change this to like 100% here. And then move around. You can see how this affects the background color of my high button. All right, I have a gradient from red at the bottom to black at the top. Furthermore, if you take a look at the XAML that was generated from the changes I made in the properties window, you can see that we have this button dot background, and then we're creating a linear gradient brush with some attributes of starting point and an ending point, and then a few gradient stops. All right. This is called the property element syntax and is in the form of the name of the control, in this case button, and then the name of the property, like background in this particular case. And so a good example here is the linear gradient brush. The term brush means that we're working with an object that represents color or a series of colors like we have here, from one color to the next, from black to red, from top to bottom. So I like to think of the term brush like a paintbrush that you would paint a wall with. This particular paintbrush will create a gradient that's linear in nature. It'll just evenly distribute the colors between black and red in this case. Now, admittedly, you'd never want to do what I'm doing here in this code example because it goes against the aesthetic of Windows Phone 8 applications. I don't think gradients are a really good background color unless you have a really good reason to do that. But let's pretend for now that we're expressing our individuality by using a gradient color as the background color for a button. So as you can see, if we want to define a linear gradient brush, we have to supply quite a bit of information here, right? But even this is a shorthand version. Like, let me paste in what I think will actually work here. I'm going to paste in some code like so, and nothing really changes as far as the visualization of it, but this is a more correct or the actual full definition for that linear gradient brush. I was able, you'll notice that a lot of things are omitted from this version right here to this version here, okay? So why were things like the gradient stops collection and so forth omitted in the shorter version? Well, this is done for conciseness and compactness, and it's made possible by an intelligent XAML parser that, in this case, is built into Visual Studio, but also is built into the compiler. So first of all, the gradient stops property is the default property for the linear gradient brush. So since it's the default property, you don't even need to use that. So we can just eliminate that from here and from here. All right. Next of all, gradient stops is of type gradient stop collection, which implements iList of t, and the t in this case would probably be of gradient stop, this object that we have defined beneath it. And so given that, it's possible for the XAML parser to just deduce what we're trying to do here, and therefore we don't have to be so explicit in all of those additional, the name of the property element syntax and the name of the objects. We can just give it, say linear gradient brush, and give it to gradient stops, and it knows, oh, you're trying to create a collection of gradient stops where the red begins and the black ends, essentially. Okay? So the moral of the story is that XAML allows us to create instances of classes declaratively, and we have a granular fidelity of control to design user interfaces using XAML. But even so, the XAML parser is intelligent, and it doesn't require us to include redundant code, so we can shorten things as long as it has enough information to create the object graph correctly and to represent the idea on in a visual sort of way like we've done here, then it should be just fine. Okay? So to recap, we've learned a lot about the syntax of XAML. Most of XAML is pretty straightforward, but there's a few things that were not quite as obvious, and hopefully they are a little bit more obvious now. So first of all, Just keep in mind that XAML is simply an implementation of XML, and it relies heavily on schemas and namespaces to adhere to contracts so that different applications can create, interpret, and display or compile XAML code. And that's the reason why we have all these namespace declarations in the page element itself. Secondly, the purpose of XAML is to allow for a compact, concise syntax to create instances of classes and set their properties. And so we compared the procedural version of this page, or essentially the button here that we created in C# versus the declarative version of the button that we defined in XAML, and we can see how much more concise the XAML version is. Third, XAML requires less code due to its built-in features like property type converters, allowing us to just use literal strings instead of the full class name, including all of the namespaces that lead up to that class or that enumeration. And it allows us to do things like we saw here with default properties and to infer certain things about our object graph that we don't have to define explicitly, like we just talked about here near the end, for complex property settings. And we learned about the embedded syntax style and the embedded nature of elements, which suggests relationships between visual elements. So here we can see that the button and the text block are children of the grid control. So we would expect there to be a children property, which is a collection of UI elements, okay? And the grid is a child of the page itself, all right? And then we also talked about default properties. I think I just mentioned that a moment ago. All right. So next up, let's take a look at the grid control for layout. We've done some pretty simple things here, just using margins and alignments, but let's talk about that in more depth in the next lesson. And we're also going to talk about XAML's attached property syntax and how events are wired up in the very next lesson. So we'll see you there. Thank you.